Oh, goodness. It was on the Monday before you guys had that Tuesday off that we learned this stuff. So that was when we did that stuff there. So we will continue it, but with proofs now. So again, if you don't have this sheet of paper out, get it out so we can get to work. So it's just another step in the process. So you still need to prove the triangle is congruent first. So that's the first thing you need to do. So what we've been doing the past couple days, you still need to do first. But after you do that, you know that... Brandon, Dylan. But once you know those two triangles are congruent, then all 6 of its corresponding parts are also congruent. So let's name all 6 corresponding parts if triangle ABC is congruent to triangle DEF. So give me 2 angles that are congruent. Somebody raise their hand and give me 2 angles that are congruent if we know those 2 statements are congruent. Ayana. Angle A is congruent to angle D. Okay, give me another set of congruent angles. Give me another set of congruent angles if you know ABC is congruent to DEF. Dylan.
B is congruent to E.
All right. What's another one? There's one more. Brandon?
Angle C is congruent to angle A.
Okay, so those are the angles that are congruent. Those are the 3 angles. We have 6 corresponding parts. The other corresponding parts are called sides. What sides are congruent? Give me a side that is congruent. Ayana? AB and DE. You'll notice they are lined up in this statement here. They're also in between the double and single dash on our diagram, if you want to look at it that way. Okay, another set of congruent sides. Dylan.
BC and EF.
BC is congruent to EF. So again, BC is between the 2 and the 3, and EF is between the 2 and the 3. They're also the last 2 pieces in our statement. Last 2 that we need to say that are congruent. What are my last 2 that are congruent, Jordan? AC and DF. All right, so do you guys remember when we did this that one day now? So that's kind of, you're going to be using that idea in the proofs. Notice none of them are fill in the blanks. So I'm hoping that we can do this. Raise your hand, just give me I just want to have an idea. Raise your hand if you prefer 2 column. Raise your hand if you prefer flow chart. So it's like half and half. So what I'll do is I'll switch off every other one and do a 2 column, then a flow chart just to give you guys both, because there's half and half of you, okay? Does that seem fair? Okay. And not at all? Okay, sounds great. What do you need me to do, Bryce? Oh, okay, that's not going to happen. So good try, though. Because, you just need homework every day.
You needed to learn, Bryce.
I can survive without homework.
Yes, you could survive. Now, I don't know if your grade could survive without homework.
No, it wouldn't go anywhere.
Yeah, but then you get a test, and you wouldn't know what you're doing because you never practiced it.
Well, no, you wouldn't know what you were doing if you just didn't pay attention to class. You don't need homework to pass the test.
Some people do, actually. But we're going to move on from this conversation.
Drop stalling.
So DE bisects BC. So DE bisects BC. What do you know because DE is bisecting BC? So looking at number 3 in that step-by-step process, which one of those are you going to be using? What kind of thing are you going to be using there from step 3 on that list? It is a... Brandon?
Segment bisector.
So you're going to use a segment bisector. So segment bisector says that 2 segments are going to be congruent to each other. So DE is slicing BC into 2 congruent pieces. So again, DE is slicing BC into 2 congruent pieces. What are those 2 congruent pieces? Go for it. Cameron, go. It's cutting BC though. So what are the 2 congruent pieces? This is the knife. No, that's the knife. I'm chopping.
BG and GC.
There you go. BG and GC. And that's the definition of a segment bisector because those are segments. Okay, we know that DB is parallel to EC. So DB, we use arrows, is parallel to CE. So those are my parallel lines. What transversal do we want to use this time, guys? What transversal do you guys want to use? Tucker, what transversal do you want to use? Nothing on there. Like on your diagram, which transversal do you want to use to connect those parallel lines?
Wait, what?
So BD is parallel to EC. Do you see how I have those outlined in purple up there?
Yeah.
What is a transversal that connects the two parallel lines? So transversal means a line that goes through both parallel lines.
BC.
So we'll use BC. Okay. What do you guys look for when you see parallel lines? What should you be looking for? Alternate interior, corresponding angles, any of those things. So, Madison, what are my alternate interior angles if these two lines are parallel and we're using this green highlighted line as a transversal? Yeah, which ones are the alternate interior there? What? What'd you say? Those are not angles. Remember, alternate interior is an angle. So looking at the diagram, Madison, an angle is going to be formed by one of the parallel lines that's in purple and the transversal that's in green. So what is an angle being formed by a parallel line and the green transversal? Are you talking about these two angles here when you say that?
Yeah.
Those are not formed by those two. Those two are not the alternate interior angles. Those are something else we can talk about later, though. Look at this. This is a purple line that connects to the green line. Do you see how it just formed an angle when I did that? What is that angle? And what is the other one? Okay. So yes. So angle DBG or just angle B is fine. So DBG, if you say angle B, that counts, is congruent to angle GCE or just angle C by the alternate interior angles theorem. Does that make more sense what I was saying when I said the parallel and the transversal connect to make the angle? So if you just follow it with your finger, you should be able to form an angle. Okay? Okay, so we've kind of exhausted all the givens unless you want to use a different transversal. That's your choice. Or you can use number 2. Or you can use number 2 and look for reflexive or vertical angles or base angles theorem or anything like that. So do we have any of those situations going on here? Do we have any of those? Ben, what do we have? And how would you name those vertical angles? CEG is this angle. Remember, what is your vertex of the vertical angles? Where's the point where your vertical angles are at? G. So G needs to be in the middle of your angle. So try again. Perfect. There you go. Do you understand what I just said there? Okay. So guys, I'm trying my best to give you guys different ways of looking at things. If it's not making sense to you, please obviously let me know. Okay, do we have enough information to prove these triangles congruent? Do we? We have 3 pieces of information. Remember, we are not proving the triangles are congruent. We're trying to prove that corresponding parts, so BD and CE are congruent. So we need to prove the triangle's congruent first. So can somebody, I think you're already writing it down, Lexi. Can you tell me the name of one of these the name of the triangles to create the correct congruent statement? Triangle what? Start with either triangle. It doesn't matter which one. So just name one of the triangles first. So triangle BDG. So what does the other one have to be named like if you started at B? What angle would you have to start with down here?
C.
Good. Then what would you have to go? If you went to D from B to D, what would that one line up with?
E.
E, good. And then,
E.
there you go. So do you see how it does matter? What's the reason she can say those 2 triangles are congruent? What is the reason you can say those 2 triangles are congruent? Is it?
Side angle? No.
Is the side between the 2 angles or outside?
Side angle?
There you go. So now that you know that those 2 triangles are congruent, any of their pieces are also congruent. So now we can say, because those 2 triangles are congruent, BD is congruent to CE by CPCTC. Corresponding parts of congruent triangles are congruent. Okay? So that means corresponding parts of congruent triangles are congruent. So we have corresponding parts in BD and BC, or CE. If you look here, BD and CE are lined up in our statement, right? So they're the corresponding parts of 2 congruent triangles. So we just proved these 2 triangles congruent. So therefore, they are congruent as well. So notice it's the same thing we've been doing the last couple days with just one more step. Okay? So if you've understood what you were doing the last couple days, you should be fine. If you haven't, you might want to come see me. So we're going to do a flowchart proof on the next one. So the first thing we know is AB is congruent to CB. So I'm going to write AB congruent to CB, and that is given. Can you come up with anything from that? Can you come up with anything else from that? No. So I'm just going to have it marked and move on to the next one. The next thing we know is angle C and A are congruent. So angle A is congruent to angle C, also given to us. Can you come up with anything else from those 2 being congruent? Okay, the next thing we know is BD, or is that DB? DB bisects angle ABC. Can we come up with something from this one? Yes, we can. So I'm going to draw an arrow to a new box. So we know that BD is the knife that is cutting this fabulous angle here. So ABC is our angle, and it's being cut by BD. What angles do you know are congruent? What angles do we know are congruent? I know, Jordan, you had your hand up. I'm going to let other people process too. What 2 angles would be congruent if that is the one that is cut? So if you guys want to try to write them down on your piece of paper first, and then we'll see if you guys are right, that might be good. So tell me the 2 angles that would be congruent and write them down on your paper. Write them down on your paper, unless you're using pen. Maybe just think about them in your head just to make sure. But what 2 angles do you guys think it would be? So do this for yourself, just to make sure you're understanding, okay? It's okay if you get it wrong. That's why we use pencil. We make mistakes. We're human beings. That's okay. Jordan, do you want to tell me the 2 angles you think are congruent there?
Yeah, I got angle ABD and CBD.
Did you get angle ABD congruent to angle CBD? You could have also written it this way. So 1 second, look at your paper. You could have also written angle DBA and angle DBC. Did you write those two angles down? If not, what is your question for me? Because you probably have a question like, what the heck, right? Like, what is the angle? So are you guys having trouble seeing those angles, or did you guys write down the right things?
I just guessed and I was right.
Is it pretty obvious if you're tracing it? Do you see how I trace it in different colors, like which two angles are there?
Yeah.
So that's kind of why I do that, different colors. If you have highlighters and stuff, that might be helpful. So before we move on, we have enough information to prove these two triangles congruent, right? But let's stop for a second. Some of you guys might have wanted to use the reflexive property at some point here, right? Do you guys notice that BD is being sheared? The problem with that, if we just ignored this information here, it would have been angle side side. Can you use angle side side? No, so that's why that other piece of information needed to be there. But we can prove the two triangles are congruent, so I'm going to put an arrow here, an arrow here, and an arrow over here.
Wait, if you would have put BDA and then BDC, would that be right too?
No.
How do you know that it's...
B has to be in the middle because that's where the top of the, or the point of the angle is. Do you see how the angle is being formed right there at B? The angle is being formed right there at B. So whichever place the angle is being formed at is the middle letter. Okay? Okay, give me the triangle congruence statement. Dylan Deptula, which two triangles are congruent? Make sure they line up correctly. So I always just start by naming one of them. I don't really care which one you name first. Okay, so you have ABD. Which angle needs to line up with A? C and A are both congruent. We have those marked, okay. What needs to line up with B? Which one's the same as B in the other triangle? B is right here, so it's also B in this one, so it's CB. What? So you have two CB. What's the third letter in this triangle? What? Perfect. Okay. So why are those two triangles congruent? Landon, why are those two triangles congruent?
Reflexive property.
They are not congruent by the reflexive property. You have it written right on your paper. What do you have on
Side
your
angle side.
There you go. You had it right. So the two triangles are congruent by side angle side. Is that correct? Do we have two sides, Landon? I shouldn't have said that was correct. Did you use the reflexive property in your proof?
No, my bad. Whoops.
No, okay. So mark your diagram, and let's look at this. Do we even have two sides marked, Landon? Up on my piece of paper, or on my board?
No, we do not.
So what is this one actually?
Side angle. Sorry, I'm just so tired.
It's not side angle angle. The side is between the two angles. So it's angle.
Side angle.
There you go. So once you know that the two triangles are congruent, you can say corresponding parts of congruent triangles are congruent. So the corresponding parts coming from that, we know then that AD, which is right here, is congruent to DC. AD and DC line up in our statements. And that's by CPCTC. So corresponding parts, AD and CD are corresponding parts of congruent triangles are congruent. Okay? Does everybody have that one there? Okay, we're going to go back to a 2-column next. Unless, I've noticed that some of you are doing flow charts either way and some of you are doing 2-column either way. I do not care as long as you're getting the right proof written down. Does that make sense? Obviously, you like something different than how I'm doing it. You need to do it the way that makes more sense to you. I will grade both of them, so it doesn't matter to me. All right. So we're trying to prove LN and DB congruent. So LN and DB are part of these two triangles here. Do you guys see that? LN and DB. We have lots of triangles going on here, so this one's kind of confusing. So we have to figure out which two triangles we're trying to prove. Do you guys see that? Because technically, we have two triangles here, and then we have bigger ones, right? So LN and DB are part of these two and a part of the bigger one, so it's going to be one of those two triangles based on the information we know. So one of those sets of two. So DL bisects BN. So what kind of bisector is this? What kind of bisector is this?
Segment.
It's a segment. So Bryce, DL is the knife that is cutting BN. So DL is slicing BN into two equal pieces. What are the equal pieces?
BX and XN.
Perfect. So BX and XN are congruent by the definition of a segment bisector. So we've done that.
How much of that is 2?
No, because it's not. So the one that we did as 2 before. Oh wait, that was in the homework. Sorry, I thought it was in the notes. As 2 congruent pieces, like as 2 dash lines, you mean?
As 2 of those, yeah, because there's already one in the D and L.
That's an angle. So angles use arcs
Oh wait, yes.
and side. But you could use 2 if you wanted to, as long as you do the same amount on both. Tucker?
We have used the angle bisector there to get LBX equals EBX.
You cannot, because it doesn't say that that angle, that line is cutting the angle. It says it's cutting the line. Do you see that? Okay. So then the next thing we have is angle XLN is congruent to XDB. So do you think we're going to be proving these 2 smaller triangles or the 2 larger triangles? What does it look like based on the information we have so far? Does it seem like the 2 smaller triangles or the 2 larger ones? It's the 2 smaller ones we're looking at. So we're looking at, just so you guys are aware, we're looking at this triangle and this triangle here, okay? So what's another piece of information we can pull from that diagram that would be helpful for us? What can we pull from that diagram? We have vertical angles. So, Alana, you can do this. Name the angle correctly. BXD, perfect. That's one of them.
LXN.
Perfect. So angle BXD is congruent to angle LXN by the vertical angles theorem. And now we have enough information to prove the triangle's congruent, right? Because we have angles marked and a side marked. Cameron, if you're not doing something you're supposed to be doing, please put it away. So, Corey, what are you 2 triangles that are congruent? Again, I always start by just naming one of them because it doesn't matter for the first one. Just start the first triangle off no matter what.
BXD.
Okay, so now you have to be very careful to line up the right angles and the right sides. Does that make sense? So which angle in this one here lines up down here?
L.
So L has a single mark and D has a single mark, but B does not. So does B line up with L?
No, N does.
N does, okay. So N does with that. What does X line up with? This is X right here, by the way. So you have B, X, D. So X is right here. What's the other one in this triangle then? X again. And then what does D line up with? L. Okay. So we've got that. Why can Corey say that those 2 triangles are congruent? Why can Corey say, Ben, that those 2 triangles are congruent? So looking up here, Ben, do you see that we know 2 angles and a side? So it's either going to be angle, angle, side, or angle, side, angle. Which one is this one? So is it angle, angle, side, or angle, side, angle? So the sides between the 2 angles? What'd you say? So angle, angle, side, or angle, side, angle? Angle, angle, side. Do you see how the side is not between those two angles? So that's why it's angle, angle, side. So now that we know those two triangles are congruent, LN and BD are corresponding parts. LN and BD are corresponding parts of two congruent triangles, so therefore they are congruent. So we can say LN congruent to BD. By corresponding parts of congruent triangles are congruent. CPCTC. Okay, let's look at the next one. That's because the air kicked back on. All right, this one's actually pretty easy. So we know that MN is congruent to NO. Can't come up with anything from that. I know that MP is congruent to OP. So I've exhausted all my givens. I can't even come up with anything from those givens. Is there something else I know based on my diagram? Sophia, is there something else I know based on my diagram? Okay, so how would you name that? Perfect, and that's the reflexive property. Do we have enough information to prove the two triangles congruent? Do we have enough information to prove those triangles are congruent? Okay. So Cole. Which two triangles are congruent? Name them.
Triangle NOP is congruent to NMP.
So NOP goes 1 to 2, and MP goes 1 to 2. Perfect. So now we can say, because of corresponding parts of congruent triangles, that angle M is congruent to angle O. They're lined up here. They're the corresponding parts of two congruent triangles, so therefore they are congruent. Make sure you put the reason underneath. Oh, we didn't put the reason underneath it. That was my fault. We never put a reason underneath that box. Why are those two triangles congruent? The easiest one, right? I think that one's the easiest one because you don't have to worry about where that angle is at and if it's in the middle or not, or you know, and that stuff. Just 3 sides. All right. Flip to the back page when you're ready. Or are we done?
We're done.
Oh, look at that. We are done.